Hello and welcome to the Analog Devices Precision Digital Isolation Technology Training videos. This video is the 6th in the series and will focus on the end market applications for digital isolators. Analog Devices iCoupler digital isolation technology is an increasingly critical and essential element in the key end markets driving the semiconductor industry: industrial automation and smart factory, digital healthcare, automotive electrification and instrumentation. We'll show a few examples of these applications and highlight the important isolator characteristics for each one. This block diagram highlights a common use case, where a measurement signal chain is isolated from a processor or digital controller. A medical ECG front-end is shown here as an example, but the signal chain is very typical of isolated measurement applications in instrumentation and factory automation as well. SPI, I2C, or the parallel digital interface of an ADC, is isolated from the processor. The maximum prop delay of the isolator is often a limiting factor in the maximum data throughput that can be achieved. Low jitter is important to avoid degradation of the signal-to-noise ratio. EMC compliance, in the form of low radiated emissions and high noise immunity, is important in many of the applications. High cross-barrier ESD is important in medical electronics to protect patients from static electricity. Many industrial systems are subject to safety standards that require isolation. The term industrial systems covers a large and varied set of applications, which leads to a wide variety of interfaces that must be isolated. These include standard digital I/O, I2C, RS-485, CAN and LVDS, to name a few. High noise and transients immunity, as well as low radiated emissions, are important because industrial environments tend to be very harsh and filled with interference. High-performance timing leads to smoother operations of robotics and faster, more robust data throughput over longer cable lengths. This block diagram shows the power conversion stage for an electric vehicle drivetrain inverter. The signal chain is very similar for industrial motor drives. A high-voltage bus is switched across the motor windings by high-power switches to create rotation. The switches are controlled by low-voltage electronics using isolated gate drivers. There are many other points throughout the system where measurement or control must be achieved using isolated communications devices. Faster and higher power SiC and GaN devices require more protection from overcurrent events. These faster power devices also generate high common mode transients, placing a higher CMTI requirement on the isolators. The trend towards higher bus voltages means the isolators must sustain higher working voltages too, and can be offered in larger creepage packaging. Analog Devices has many digital isolators that provide trusted safety and data integrity. Thanks for watching this series of videos. We have many videos available across our extensive portfolio of precision technology. Go to analog.com or follow the links highlighted below.